Hello Geotech Masters, welcome back to our comprehensive tutorial series on the standard penetration test guided by the ASTM D1586 standard. I'm thrilled to continue this journey with you. In our previous sessions, we discussed the sampler's components, understanding the role of the liners, drive shoes, and retainers, and critically, the absolute importance of sampler maintenance for accurate results. Now, as we move forward, we are going to dive into another critical component of the SPT, the hammer, anvil, and the entire hammer drop system.
Have you ever wondered how the hammer's energy is delivered consistently? What makes an automatic hammer different from other types, and why are they often preferred? How can a heavy hammer system actually compromise your test results in certain soil types? And most importantly, how do we ensure the hammer is delivering the precise energy needed for a reliable SPT reading? These are the crucial questions we will answer today, helping you master the next vital step in the SPT. Let's begin by looking at the various hammer drop systems used in the standard penetration test. The standard specifies a required hammer weight of 63.5 kilograms. This hammer must be a rigid metallic mass, designed to strike an anvil, creating a steel-on-steel contact when dropped. The entire system needs to allow for a constant and unimpeded vertical fall of 750 mm onto the impact anvil, which is firmly connected to the drill rods. The anvil itself acts as an energy damper, meaning a larger anvil can lead to lower energy transmission to the rods. It's also vital to ensure that friction between the drive weight and the guide system is minimized, requiring periodic inspection, cleaning, and lubrication. The ASTM standard